So, in this session, we will be seeing the applications of membrane processes in wastewater treatment. So, as you know, membrane processes are nowadays very much used, mainly in the water purification. It is used in a large way. Same thing, it is also used in wastewater treatment also. So we will see what is the membrane processes. So membrane processes, membrane is generally a selective barrier that permits the separation of certain species in a fluid by a combination of mechanism, that is sieving and the diffusion mechanism. Okay.
सर उनका दरवाजा खुला हो तो बंद.
Yes, okay.
Hey, Shivendra is coming to close the door.
पीछे इसको बंद कर दो. Okay, so it is a barrier that permits the separation of certain species in a fluid by a combination of sieving and diffusion mechanism. So here we are using the sieving mechanism, just like sieves are there at different size, and from which this pore size the particles are retained on that. So like that. So some particles which are more than the pore size of that membrane will be retained on the membrane and they cannot pass. And another is a diffusion mechanism. You know, diffusion is from a higher concentration to lower concentration, the particles are flowing. So we are using the combination of these mechanisms. Membrane can separate particles and molecules, and over a wide particle size range and molecular weights can be separated by this. Now, types of membrane processes generally used are microfiltration, ultrafiltration, nanofiltration, reverse osmosis.
Excuse me, sir, your slides are not changing, sir.
It is not changing?
Yeah, it is on the title slide only.
Is it changing now? So can I do in this mode or slideshow mode?
Slideshow.
Is it changing now?
No.
No, I think in the slideshow mode it is not changing. So maybe I will convert it into PDF and then I will show. It will be easier.
Now it is
Yes,
in
sir, now
PDF.
yes,
It is
sir.
now changing also.
Yes,
Yes.
sir. Change.
Yes. Oh. So, yes, so these are the different types of membrane processes: microfiltration, ultrafiltration, nanofiltration, reverse osmosis, dialysis, and electrodialysis. Apart from that, we can have other types, which is the recent one, that is forward osmosis, and for evaporation, that is also used. That we will see. Now, what is the applications of this membrane processes? Uh, these processes will be used for desalting the seawater, then treating brackish groundwater, then water softening, wastewater recovery, then it will be remove the color, odor, and other organ contaminants. So these are all the applications of the membrane process. Like as you know that in water treatment, we are generally removing the solids. Uh, you are aware that we are very much using the reverse osmosis process and another ultrafiltration or microfiltration for the water treatment. So, like we should know what type of solids are there. Generally, as an environmental engineer, you should know that solids can be dissolved solids and the suspended solids. So, uh, as you know, suspended solids are the solids like if we find in the environmental engineering lab for the solid determination, how we are finding out the suspended solid and how we are the finding out the dissolved solids. It's very simple. What we are doing, we are taking the some amount of water, let us say 100 ml water, filtering it, and then whatever is filtered, we just put it, let us say if it is filtered uh, or if you want to have the total solids, so you don't have to filter, and then just take 100 ml and keep it in the oven, just uh, uh, let it evaporate, and after some time or after one day or when it is evaporated, then again you check the weight of the beaker from where you have put back at that 100 ml. So the if you subtract this, you will get the total solids. The weight of beaker, empty beaker, and whatever the weight of the beaker after evaporation of the water. So that two readings, if you subtract, you will get the total solids. How will get the suspended solids? That is very easy. What you do, you filter the 100 ml, and when you filter the 100 ml, whatever the water that you get, that is in the beaker, just keep it in the oven, and when this will be evaporated, what you will get, which type of solid, suspended solids or dissolved solids, if anyone knows. Just filter the water or wastewater, whatever is there, and 100 ml, and whatever the filtered water is there, you keep it in the oven. After the evaporation, just take it out, and that weight minus the initial weight of, means empty weight of beaker, what you will get, suspended solids or dissolved solids?
Maybe suspended solids.
Uh, that will be the dissolved solids. Why? Because the suspended solids are already filtered. Okay. Yes. So that is the dissolved solids. And whatever the solids which is retained on the filter,
I can see John.
so what you have to do, that whatever the retained, that if you keep that filter into the oven, dry it, and that's, if you take the weight of the filter before and after, you will get the suspended solids. Another method of finding out suspended solid is you have got the total solids earlier, and Second, you get the dissolved solids. So total solids minus dissolved solids will be a suspended solid. Okay, so like this also you can do. Now, next is, so this TDS, that dissolved solids, is due to what? Do you know what is the content of this dissolved solids in the water generally? It can be that dissolved solids can be uh, having the salts mainly, okay, like calcium, magnesium, sodium, or anions like nitrates, sulfates, chlorides. So these salts are there generally in these dissolved solids. So in the this is the background I want to tell, because before going into the detail in the membrane system, you should know which type of solids. So dissolved solids are the solids which we find out in the lab like this. Okay. Now this if you remove the dissolved solids, okay, that is called the softening or desalination of water. Okay, because do you know what is the limit of the dissolved solids for drinking? Anyone knows what is the limits for dissolved solids for drinking water? Drinking water, what is the limits for dissolved solids, if anyone is known? If no alternate sources are there, you can drink up to 1000 also, but generally we are not going above 600 like that. Okay, we cannot drink also, it will become somewhat salty type taste is there. 500 to 600 it is more. So as you know, what is the source of this dissolved solids depend upon the source of water, from where we are taking the drinking water. Like if you are taking the water from the river or surface water source, and there is a water from the groundwater. There is a groundwater and there is a water from the river source, in which the dissolved solids will be more, in groundwater or in the river water source, if anyone knows. In which water, that is groundwater or the river water source, the this dissolved solids will be more, or salts or dissolved solids will be more, that we are drinking. This is general question just I want to ask, because that helps in giving us which type of treatment, which type of membrane treatment we will give. Just you can guess, anyone, that river water is there and the groundwater, in which more dissolved solids will be there.
So it will be groundwater.
Yes, it will be in groundwater. In groundwater, not river water.
River water probably do not need the majority of the cases the removal of dissolved solids, unless until it is near the acidine zone. Majority of the cases.
Yes, yes,
River
yes.
water does not need this.
River water, you see, the water that is a rainwater, that is just a distilled water. You know, rainwater is just a distilled water, because it is a natural distillation. The water is evaporate and it is pure H2O, rainwater. Some dissolve, like some gases may be dissolved like SO2 or NO2, some acid rain, some gases, but otherwise it is a distilled water, rainwater. And if when it comes to when it comes to the earth, what will be happening? First it will be flowing on the surface. When it is flowing on the surface, in the during the flowing, it can take some of the solids, but it is mainly suspended solids. In river, you have a mainly suspended solids, not the dissolved solids. Okay, but when this water goes into the ground, so what is happening in the when it is going to the strata of the ground, it is taking the salts from the rocks. From the rocks, this calcium, magnesium, these are taken by the water which is going downwards, and then it accumulates the dissolved solids. You know, deeper is your borewell. Borewell, you know, from where you are taking the water, deeper it is, the more tedious it will be having. Okay, deeper your borewell. Therefore, sometimes where the water scarcity is there, and if the borewell is very deep, if you take the water, it is not a drinkable, because its tedious are generally in the 3000, 2000 milligram per liter, which is not a drinkable form. Okay. So therefore, the TDS of groundwater is more. Therefore, if you want to remove the dissolved solids, what do you do? We use the membrane processes which are removing the dissolved solids. Okay, which can remove the dissolved solids. So that we will see which are the membrane processes which can remove the dissolved solids efficiently. Okay. So sometimes like one of that is the RO system, we will just see. So reverse osmosis system is one of the system which can remove the dissolved solids completely. Some not completely, but 90% of it will remove. Okay. So like in our home, we are having this RO system or that, and what is happening that sometimes your source is river water, like let us say Mumbai is there, your source is the river water, or in the Surat we have a source is the river water, Tapi river. So if a source of river water is there, you know what is the dissolved solid content of a river. If anyone is knowing the dissolved solid content of the river, it is just around 120, 150 like that only. Okay, so it is the dissolved solid content is very. I think this name of this. Your mic is on, sir. Yes. Dissolved solids. If your source of water to your house supply is a river water supply, you don't need RO. Nowadays the people are moving towards RO system, but you are not checking your dissolved solid content. First you check your dissolved solid content. If it is less than 300 around, or less than 400 also, there is no need for going for this RO systems, which are somewhat costlier in operating also, and in purchasing also. So we do not need this type of RO type system, reverse osmosis type system, if our dissolved solids content is less. Like if we should know what is the source. If it is a groundwater source, sometimes your dissolved solids is more than 500. So then you can go for your RO membrane type system. Otherwise, you can have ultrafiltration or microfiltration, followed by like AquaGuard UV. So they have only ultrafiltration, microfiltration, and then they have this bacterial removal technology, that is UV light is there. So only you need to there in the river water sources, their dissolved solids content is not very much a problem. Okay, there the problem is suspended solids and bacteria, virus. That is the problem in the river water. You don't need to remove dissolved solids there. So what you need? You need some smaller filters which are very easily available, like microfiltration or ultrafiltration with the UV light to disinfect the water of the bacteria, viruses. That is the only thing you require. No RO is required for that source. Only the ROs and this are required when you have a high TDS, total dissolved solids greater than 500. Okay. Why? Because if you use RO for this type of system, this type of water, river water, which is having only 150. So 90% will be removed and you will get only 10 to 15 milligram per liter after the RO, and that is not desirable also for our health. If you remove all the dissolved salts and you drink it, its taste is also nothing. No taste will be there, and for your health also it is not very good if your dissolved solids become zero. Okay, so this is just I told you the some points that is required. So this is so that is about the water. Okay, so in the water, this type of decisions we have to take to which type of membrane. Now we'll see the in wastewater also. In wastewater, whatever the recovery, where we want out the recovery of something, we can use this membrane processes. If we want to remove the organic contaminants or we remove color order, there also we can use this water. And then we can use this membrane processes when we are using some processes. So like in you see bioprocesses are there. There we don't want the dissolved content of solids. So there we use the this system, membrane system, to remove the solids or salts. Like in boiler also we can, before the boiler feed water, we can use this. So like this, there are many applications we will see for the particular type of. Now membrane processes are of many types according to the driving force. Like if the pressure driven operation is there, then microfiltration, ultrafiltration, nanofiltration and reverse osmosis. These are the pressure driven operations. Concentration driven operations are dialysis, pervaporation, forward osmosis. And electric potential gradient driven operations is electrodialysis and membrane electrolysis. And temperature gradient driven operation is membrane distillation. So generally if you see microfiltration, ultrafiltration, nanofiltration and reverse osmosis, they are generally by pressure we are applying on the membrane, and due to that the solvents will be going out of going through the membrane, like water is moving through the membrane, but the solids are retained on the membrane. So like that these operations are there. Dialysis, pervaporation, forward osmosis is generally due to the concentration of that we will see what is that. Electrodialysis also we'll see. In electrodialysis, we use the electric potential gradient, like cathode and anode we use, so that the cations and anions will be they will be attracting towards that membranes. Okay. And there is a temperature gradient driven operations like membrane distillation. So general characteristic, if we see that microfiltration, the driving force is that pressure difference or the pressure is there, and separation mechanism is sieve. Sieve, I have already told you that minor pores are there. From the pores, as you know, we are using the some sieve in our house also for removing the higher content, like for making maida from atta. Okay, if you sieve it, very fine sieve, the coarse particle will be separated. So that type of system is there. that whatever the pores solids are there, that will be separated, they cannot pass through the membrane. So and this pore size is greater than 15 nanometer, and the operating range is generally 0.08 to 2 micrometer. Now the permeate, which is permeate that will be coming out is water plus dissolved solid, means water can go out of this and some dissolved solids also can pass through it, means it is not efficient in removing the dissolved solids, this microfiltration. So water plus dissolved solids, it can remove the suspended solids. Like you can see what it can remove. It can remove TSS, that is suspended solids. It can remove the turbidity of water. It can remove the protozoans and some of the bacteria and viruses. You know, the size of the bacteria is less, very less, and the virus is smaller than bacteria also. Then ultrafiltration is there. After microfiltration, ultrafiltration, here also we give a pressure and there is a sieve mechanism is there. The pore size is 2 to 50 nanometer and the operating range is 0.005 to 0.2 micrometer, and here water and small molecules can pass through it. Okay. So this can remove macromolecules, colloids, most bacteria and some of the viruses. So ultrafiltration can remove most of the bacteria, but not all the viruses cannot remove from it. Then nanofiltration is there. Here also hydrostatic pressure difference, but here the sieve plus solution diffusion also will be there. So both the process will be there, and the size is micropores, that is less than 2 nanometer, and the operating is 0.001 to 0.01 micrometer, and water plus very small molecules. So here we can remove small molecules and hardness also. In reverse osmosis, same thing is there, but you can see the size range is still smaller, and this type of pore size is called dense pores. Okay. This greater than 50 nm, it is called macropores. 2 to 50 nm mesopores, less than 22 nm, and lesser than 1 or that, it is called a dense type of membrane. Then dialysis. Dialysis generally due to concentration difference. So if the concentration of one side is lesser, concentration on one side is more, then the liquid will be flowing like that. Okay, and when it is flowing, what is happening? Some small molecules, they are retained, and large molecules are retained, and the small molecules can pass through the membranes. Okay, so the permeate description is water plus small molecules. So macromolecules are retained. Now, if we see this like this, you see here pictorial microfiltration, the suspended solids are removed and other things can pass through it. Okay, multivalent ions, macromolecules, monovalent ions, and water can pass through them. Only the suspended solids can be removed by microfiltration. If you say about the ultrafiltration, you see the macromolecules can be retained and others can pass through it. Then nanofiltration. Nanofiltration can remove all the things, only it cannot remove is the multivalent ions. Means, multivalent ions can be retained and it can remove all other things. Okay. So multivalent ions can be removed by this, and other things it can permit. Okay. So dissolved solids also can go through the NF. But if you use the RO system, dissolved solids also cannot go. You see this monovalent ions. Now multivalent ions is like calcium Ca2 plus, Mg2 plus, they are multivalent ions. Al3 plus are multivalent ions. Monovalent ions are Na plus, sodium. So that also retained in the RO, but it cannot be retained. The sodium ions can pass through the NF, but it can be retained through RO. Okay, so best to retain the total dissolved salts are the RO. RO is also can prevent the bacteria and virus to pass through it. So bacteria and virus also cannot pass through the RO, as we have seen. So now the process configuration we will see. Like here the feed is there. So the membranes are here. You see the semi-permeable membrane is there. Feed is there. The water is passing through the membranes, and the water which is passed through the membrane is called product. Whatever is not passed, that is called concentrate. Okay, that is called concentrate. Now the another name of the liquid that is passing through it is called permeate or product stream or permeating stream, and whatever is not passing is called concentrate. Other name is retentate, other name is reject or retained phase. So these are the some names which are used for concentrate. These are the names which are used for product. Like permeate. Permeate is the thing which is passing through the membrane. Okay. Now what is this membrane material made up of? Now this membrane is used for the treatment of water and wastewater. Generally it is having very thin skin. You can see here, there is a polyamide active layer here on the top, and then there is a porous structure below. So this porous structure, reinforcement polyester fabric or anything, it will provide a support to this thin layer. Okay. So membranes, and now this material of the membrane can be organic as well as inorganic. But generally for the wastewater treatment, we are using organics like polypropylene, cellulose acetate, aromatic polyamides, and thin film composites based on this that you see here. This is the thin film composites made up of polyamide layer and polysulfone support. So the membranes are made up of these materials: polypropylene, cellulose acetate, aromatic polyamide. These are organic. Okay, inorganic membranes are also there, like ceramic or glass, that can also be used, but it is generally not used in the wastewater treatment. In wastewater treatment, generally organic type of membranes are used. Now there is one unit that is called a flux. What is flux? Flux is the rate at which permeate flows through the membrane. Means how much is the, like if you see the this much of kg or per meter square per day is passing through that. So that is called a flux. Or this much of liter per meter square per day is passing, that is called, means the rate at which permeate flows per square meter of the area per day is called the flux. Now how it is removed, I have already told that separation of microfiltration and ultrafiltration is generally by sieving. Okay. So here you see the wastewater is coming like this, and the bigger particles, they are retained, and the smaller particles can pass through. This is called sieving. So this is the main membrane, and this is the skin support that I have told you like just now. Skin support is this, and the bottom there is a skin support. So the smaller these voids are there, very pores are there. I have told you microfiltration, ultrafiltration has some size of pore is more. Okay, macro pores are there. In nanofiltration, the size of pores are in nano size, therefore it is called nano filtration membrane. So this pore, mainly the pore size is the main response. So here it will be passing and like that. So mainly sieving is there. In NF and RO, what is happening that this pore size is there, but there's another thing is there, that a water layer will be there, absorbed water layer. Okay, so this will form a one layer on the this surface of the this membrane, and therefore it becomes a dense membrane, and ionic species are transported across the membrane by diffusion. Okay, by diffusion it will be transferred because there is a adsorbed water is there, and now ions will be passing through the diffusion, because diffusion, you know, from higher concentration to the lower concentration it will pass like this. So by diffusion it is passing. Now, nanofiltration can be used to reject constituent as small as 0.001 micrometer, whereas RO can reject particle as small as 0.0001 micrometer. Now we will see the typical membrane elements and modules that is used in the membrane applications. So you know that there are different modules. Like one of the module is tubular module. So this is the tubular module. So tubular module is nothing but a tube-like structure is there. The membrane is like this. Tubular membrane is like this. So water is passing like from let us say it is passing through the from inside, and from inside it the water is coming outside. Okay. So the water is going from inside and it is filtered, and the filtered water is coming outside to this space. So this is the annular space for flow. It is coming out and then it is taken out. The filtered water is taken out. So this is the tubular hollow fiber membrane. Like this is a one tube, single tube. You can have a multiple tubes here. Okay, so multiple tubes are there. You can have a hollow fine fiber also, because these tubes are somewhat more in diameter. You can have it like this. You can see here. This is the view of the fiber, hollow fine fiber. So this type of fiber can be used also. Very small fine fiber membranes are there, and that can be put into the casings, and then the water is passing through this fiber and coming out of this fiber is the filtered water. So that is also one type of you can see the configuration. Other configuration is the plate and frame module. So plate and frame module, what is happening? The wastewater is going through the, you can see the from between this, and then there is a membranes, alternatively membranes are placed. So the water is coming through this channel and going through the membranes, and the filtered water is coming out. You see the filtered water is coming out through this. So this is the membranes. The water is going out and it is filtered from both the sides. So up top also and bottom also you can get a permeate. Permeate is the filtered water. So this is called a plate and frame module. The another module which is very much common, which is used, you can see your when in your RO system also this type of modules are used, and that is called the spiral wound module. So nowadays spiral wound thin film composite modules are very, so this is nothing but the same time, but it is spirally wound like this, and you see what is happening, that feed water is going like this. This is the feed water space, and in the between this feed water space there is a spacing, permeate spacer is there. So it is passing through this membrane and coming into the permeate spacer, and in permeate spacer then it is going like this and coming into the center, and from the center you will get a permeate purified. So it is very easy, like you can see that water is passed through this permeate spacer. From there, sorry, water passed through this space, and then it is passing through the membranes, and from the membrane this permeate spacer is there in which it is going like this and then coming to the center. So this type of we can have one video also like this. Just I will show you how it is, because it is mainly it is used. Can you able to see the video?
No, no, sir.
Okay. Can you able to see?
Yes, sir.
So generally a flat sheet is taken first. So this is the feed spacer from where the water will be coming. So these feed spacers are there providing between the membranes. You see that the when it is the water is coming here, this passes through this membrane. You can see here membrane, and when it passes through the membrane, it comes to the permeate spacer. Then it will flow like this. Okay. So this is how this is working. Okay, so this is how. So you can see this type of this spiral wound membrane is there, and then this is a many companies are making it like DuPont, Doe. This is DuPont and Doe is formerly it is called Doe. Many other companies are also there. So this type of spiral wound membrane in your house also, which if you are using the RO and other systems, you will be having this type of membranes which is fitted into your filter. So the large filter will be having, you can see here, it is the large filtration. So so many this type of modules will be there in the series, and then it will be helping in filtering the water. There is another stream, that is the concentrated stream will be there, that will be removed. Okay. So what is happening when water is passing through it? There is a filtered stream and there is a concentrated stream. Now concentrated stream will be there. You may have seen in your RO system in your house. There is another pipe is there which is taking out the concentrated stream, and that is very salty. Have you tasted it? It is very salty. That concentrated stream is there. So this is how these modules are there. Now this mode of operation of this membranes can be cross flow mode of operation. Generally it is a cross flow mode of operations. Cross flow mode of operation means the feed is like this, feed is growing like this, and then it is passing through the membrane. Okay, the feed is going like this, and permeate filter will be passing like this, so perpendicular to it. Feed is perpendicular to the permeate. Okay, so the pressure, the transmembrane pressure gradient in this type of operation is PTM is equal to PF plus PC divided by 2 minus PP. What is P? P is the pressure gradient, and F is the feed, C is the concentrate, P is the permeate. Okay, feed water, you know, feed water, whatever is we are feeding, that is the feed water. So pressure of the feed water, feed stream is PF plus pressure of the concentrate stream, which is concentrating after removing the filtered water, whatever is remaining, that is called concentrate. So PF feed water plus PC divided by 2 minus pressure of permeate. Permeate is the filtered water. If you have, that is called the transmembrane pressure gradient. So that much pressure is required in operating this cross flow mode of operation of the membrane. Now another operation is direct flow mode of operation. Direct flow means feed is directly passing through this, the membrane is there and feed is perpendicular to it. Here it is, you see, the feed is parallel to this membrane. Feed is parallel to this membrane. Here the feed is membrane is like this, and feed is perpendicular directly coming to the membrane, and the filtrate will be coming out of this. So here the transmembrane pressure gradient is PF minus PP. That will be transmembrane pressure will be equal to pressure of the feed minus pressure of permeate. Now the recovery rate, how much is recovered, that will be a quantity of permeate divided by the quantity of feed into 100. That is the recovery rate. It is very simple. Whatever the feed water is coming out, whatever the permeate water is coming out, and whatever the feed water is there, divided by into 100 will become your recovery rate. Like in your house, from your tap, the water is going into the filter, that is RO filter, and you are getting the water in your tank, that filter tank from RO, that is called permeate, and some water you are getting at the waste, that is called concentrate. So the water which you are getting actually for drinking, that is QP. Water that you are feeding from your tap is QF. So QP by QF into 100 will become the recovery rate. So microfiltration, you can use any type of membrane configuration that we have talked about, like you can have a spiral round, you can have a tubular, any type. Sometimes when it is chalked, you can wash it with back flushing or air square. It is highly automated. You can add coagulant also to enhance filtration, and it is generally used for pre-treatment of RO or NF. Okay. As you seen, your RO will be in your system, in your house. You have seen that. Why I am connecting with your house, because you are seeing in your house there is a RO filter there. So whatever the membrane system will be there, it is in your machine. But outside of it, before going to that, there is some filter, that is outside of that. That is the microfiltration. So you have to give some pre-treatment before going to RO. Why that is required? Do you know? Why this pre-treatment by microfiltration is required before going to the RO membrane? Anyone? Why we give pre-treatment with microfiltration first, and then the water will be going into reverse osmosis membrane?
Sir, I think to remove the solids.
Yes. Why? Because coarser solids, if you also go to RO membrane, it is very small polar size, pore size, and it is very costly also. RO membrane is very costly. If you don't provide this microfiltration is very, you see 200, 300 rupees or one, and RO membranes are around 4,000, 5,000, depending upon the how much capacity is there. It's costly. So if you directly feed into RO system, in the no time it will be clogged. Okay. So therefore, what we do, we use this microfiltration first as a pre-treatment, and then we supply to this RO system. Therefore, in our house, first there is you see that white color, you can casing will be there, in that microfiltration is there, and then it will be feeded inside your system. There the membrane RO system is there. So this is the membrane filtration. So it is used in wastewater treatment, water treatment plant for reducing the turbidity of the water. Okay, not it cannot reduce the dissolved solids, but turbidity or suspended solids it can remove. Microfiltration. So ultrafiltration and microfiltration can remove color and odor causing organic virus and other, but not the dissolved salts. Microfiltration can remove the suspended solids, turbidity, some protozoa like Giardia, but not color, virus or dissolved solids. Ultrafiltration also is the same. It is a concentration process. Energy is required by forcing the liquid through the membrane, and it is used in the industry for recycling of metal containing alkaline cleaner waste and the paints. So for recycling of metals, we can use this in the industry, and also the reduction of metals in the industrial waste also we can use it. Okay, because the metals which are present in the wastewater, that is having a near to the suspended solids, so it can be removed by the ultrafiltration. Now, ultrafiltration does not change the chemistry of water. That we already know, that it cannot change the chemistry of water, because it cannot remove the dissolved solids or dissolved salts, we say. Only it can remove the suspended solids. So to obtain potable water from surface water, but if it contains algae and bacteria, it can be used. It has the same water quality with coagulation and flocculation. That whatever this coagulation and flocculation we are doing in the water treatment plant, the same thing is done by the ultrafiltration if you use this membrane. Okay. So instead of coagulation, flocculation, if you use the ultrafiltration membrane, then the same thing you will get. So larger pore size is there and they require much lower differential operating pressure. So ultrafiltration is also, it can be used as cross flow or transverse flow. Any membrane configuration can be used. Okay, so this I think we have already covered. So this ultrafiltration can replace several conventional processes like this flocculation tank and clarification, as well as sand filtration can be removed if you use this ultrafiltration. So these three things can be removed if you use the ultrafiltration membrane. So directly in our water treatment plant that is there, which is taking only river water, there if you use the UF system, you do not need all these three things. Flocculation tank, clarification tank, sand filtration, everything you can remove it. Directly feed it into it and then post chlorination you do. So whatever the virus bacteria which can pass through UF can be chlorinated and then it can be treated water. Okay, so it can be considered as pre-treatment before RO, or you can use it for the surface water also in the water treatment. In the industrial waste, it can be used in metal industry for separation of water oil emulsions, automotive painting industry to separate the dye from washing water. Then in pharmaceutical industry also for the separation of enzymes, in food industry also. So if we want to separate the dye from washing water, we are using in automotive painting industry. Water oil emulsions can also be separated by using this. So these are all the applications of this ultrafiltration in the industrial waste. So as you see the more applications, okay, microfiltration and ultrafiltration is used in the membrane bioreactor. Okay, in membrane bioreactor process, we are using the microfiltration and ultrafiltration only. We are not using RO there in membrane bioreactor. So we will be having one session on membrane bioreactor also. I have also told you something about this in biological process. So there we are using the microfiltration and ultrafiltration. In anaerobic biological treatment also, this membrane is used to separate the treated wastewater from the active biomass. That is the same thing. It acts as a sedimentation tank. Okay. In ambient also, it is acting as a sedimentation tank. In sedimentation tank, what is the function of sedimentation tank? Sedimentation tank removes the biomass from the treated wastewater. So this is also doing the same purpose, microfiltration, ultrafiltration. Then aeration which is done, I have told you in the biological treatment the aeration is done. So aeration can be done through this membrane aeration, plate and frame tubular hollow membranes are used to transfer the pure oxygen to the biomass. So that is also can be done, and that process is called membrane aeration bioreactor processes. Then membrane extraction biological treatment are used to extract the degradable organic molecules from inorganic constituents such as acid, base and salts of waste stream. Okay. So organic molecules can be separated from inorganics by using these membranes. Then pre-treatment for effective disinfection can be before disinfection we have to remove the suspended solids or other organic solids. Why? Because like if you do the chlorination without removing the solids or the macrosolids, there are some compounds which are formed with the reaction with the chlorine. So as a pre-treatment also we can use it. And I have already told that it is used as pre-treatment for nanofiltration and reverse osmosis. Before reverse osmosis and nanofiltration, we have to use this ultrafiltration or microfiltration. Otherwise, that will not work. RO system will not work for much time if you will not use this microfiltration, ultrafiltration before that. Now comes the reverse osmosis. Reverse osmosis, as the name suggests, it is the reverse of osmosis. Osmosis, you know, anyone who knows osmosis. In osmosis, what will be happening if you have a semi-permeable membrane? The water is passing from the fresh water to saline water, or from saline water to the fresh water. What is the process in the osmosis? Water is passing from the fresh water to saline, or from saline to fresh in osmosis?
Saline to fresh, sir, from high concentration to low concentration.
In osmosis, it is from fresh to saline. In osmosis, I'm not talking about reverse osmosis. I'm talking about osmosis. In osmosis, from fresh, osmosis is the pressure is the system that is happening in nature also. In plants, you see, in our body also, see in the cells, tissue. Osmosis is there's a membranes. If you have a semi-permeable membrane, and here the fresh water is there, which is having no salt, and here the salty water is there. So this fresh water will go into the salty water always. If you separate it with membrane, the fresh water is going into the salty water. It will be happening always. Okay. So up to how much it will go? It will go like, it is going like this, and there is some pressure which built on this side. There will be one instance where this will stop. The fresh to saline will stop. As the pressure built up on this saline phase, this will be stopping. The water is flowing from this will stop. So this head is called osmotic pressure. This head is called osmotic pressure. Okay. Now, in reverse osmosis, what we are doing? What we are doing? Applying pressure from this side. In reverse osmosis, we are applying pressure from this side, and as we are applying pressure from this side, the water will passing through it, but the salts will not pass. So this is called reverse osmosis. So reverse osmosis is what? If you apply pressure from saline side, the water, fresh water will be passing through it, but the salts will not pass through it. Okay. So this we are doing in our treatment. Okay. So what we are doing? We are giving the pressure to this high TDS water, and then it is passing through it. Okay. Now, if you want to know the what will be the water flux rate in this, so that is very simple. That will be equal to Kw delta PA minus delta pi. Delta pi is nothing but osmotic pressure gradient, and this delta PA is the average imposed pressure gradient. That whatever the pressure gradient we are applying, like here, we are applying from this side. Here we are applying the pressure, and here the osmotic pressure is there. So we have to overcome this osmotic pressure. So you have to apply the delta PA greater than the osmotic pressure. Then only the water will be passing through. At equilibrium, osmotic pressure will be equal to the delta P. Now, if you provide more pressure, then the fresh water will be passing through it, like here. So it is passing through. So that the flux rate will be given by delta PA, that whatever the pressure we are applying, delta pi is the pressure gradient of osmosis. So if you subtract this into Kw, that is the water mass transfer coefficient, that involves temperature, membrane characteristic, and solute characteristics also. Okay. Now this reverse osmosis can be, you can have elements in parallel, many reverse osmosis process in parallel, and you can do it, or you can have a two-stage system, 2:1 error. Okay. Two-stage system, 2:1 is stage 1, you have a more number of RO system, and stage 2 less, because here what is happening, stage 1 more TDS will be there, so it will be removed here, and then stage 2, the less TDS will be there, so then it will be removed like this. So two-stage system will be also, you can use it. So reverse osmosis you can use the spiral bond configuration or hollow fiber that I have told you, and you will get a very good water here. The nephelometric turbidity unit will be less than 1, silt density index is less than 3, operating pressure 150 to 1000 pounds square inch, removes greater than 95 to 99% of TDS. Now you see this much of TDS is removed. So I was talking that if you use this RO system in our domestic water where river water is coming, you will get around zero TDS, and zero TDS water is not good for health. So you should not use RO system generally for the river water where the TDS is very less. Now the application of RO system is effluent reuse. So used to treat the pre-filtered effluent for indirect potable reuse. Like if you want to reuse some water, you can pass through it and you can reuse it for your purpose. Okay, for your household purpose also you can use it. Okay. Only thing is that you have to give some disinfection. Otherwise, reverse osmosis is capable of removing all the bacteria and viruses also. You can directly drink also after reverse osmosis. No need for disinfection. But to be very sure, you can disinfect also. Otherwise, if the water is passing through RO system, generally it is bacteria free and virus free. Then effluent dispersal will be there. Reverse osmosis process have capable of removing sizable amounts of selected compounds like NDMM, that is nitrosol dimethyl acetate. That will be the compound which is used in various chemicals or in the food beverages industry. So then two-stage treatment for boiler use. For high pressure boilers, if you give the reverse osmosis, then it can be used in boilers. Why we want this type of water to be used in boilers? Because in boilers, what is happening, if you use the water which is having hardness or some having calcium, magnesium, it will form scales in the boiler. Inside the boiler, the scales will form. So you have to pre-treat it first, and then we can use the water in the boilers. Nanofiltration, if you see, that is also the same thing, but only somewhat pores are lesser than the RO system. So same application as the RO system you can have in nanofiltration also. Only thing is that the quality is not as good as RO system. So silt density index is less than 5. So it is also used for softening or special applications. So reject some salts, like it can reject Cu2 plus, Mg2 plus or Ca2 plus divalent cation, but it can allow sodium ions like that, monovalent ions. So that problem will be there. Nanofiltration is also used to treat pre-filtered effluent for indirect potable use if you want to have a potable use, and it reduces the hardness. Okay, you know hardness is caused by which ions? Everybody, hardness is caused by which ions? Which type of ions cause the hardness?
So multivalent cations. Calcium and magnesium are major ones. Rest
Yes,
aluminum, iron, and all these contribute, but it's a little bit.
Yes.
And
It should be multivalent.
Carbonates, bicarbonates, chloride, and sulfates. Whereas carbonate and bicarbonate we can precipitate by boiling. Rest we need to go for these type of the treatment for removal when we are using it, especially for the industrial purposes.
Yes, yes. So generally calcium, magnesium, whatever the divalent and more than that, multivalent ions like Ca2 plus, Mg2 plus, Al3 plus, Fe2 plus, these causes the hardness. Na plus will not cause the hardness. Okay, it makes it salty. It increases the dissolved solids also. It comes in dissolved solids, but it will not cause the hardness. Okay, only the multivalent ions they cause the hardness. So this is used in softening because multivalent ions it is capable of removing nanofiltration. So this type of RO package systems are there which are used in industries for treating their water. You see, this is the desalting plant. You see, there is so much huge. This type of plants you can see I have seen in Gujarat in the Reliance Jamnagar. They have this type of desalination plant, and this type of plant in the Gulf countries, if you the whole water system there in the Gulf countries, they are taking from the sea. They are using this type of RO systems, desalination plants are there, and the whole city is getting this water. So a big, huge plants are there in the Gulf countries mainly, if you can, because they are from the all sides they are having the sea water. Sea water is plenty of sea water is available to them, but they don't have the water or rain is very less, so they are not getting the water for drinking. So for making it for drinking purpose, we can use this RO systems. Now, in the nutshell, we can see this membrane technology, that is microfiltration, ultrafiltration, nanofiltration, reverse osmosis. This is the typical operating range, means the size, and this pressure. Pressure is this much. You see, the pressure required, operating pressure required in microfiltration is 7 to 100 kilopascal. In reverse osmosis, you can see up to 7,000 kilopascal pressure is required. And this is the rate of flux in different membranes, and the type of mainly type of the membranes will. You see, for microfiltration, polypropylene, acrylonitrile, nylon, and tetrafluoroethylene membranes can be used. But generally in all nanofiltration and reverse osmosis, we are using cellulose acetate and aromatic polyamide membranes. Now comes electrodialysis. Electrodialysis is where we are using the electricity, using the current electricity or electricity potential to remove the ions from the water. We can remove the ions from the water, like you can see here, the diagram is there. You can see here the cathode is there, here anode is there. Now you have a alternate anion exchange membrane and cation exchange membrane. Okay, AEM, CEM, AEM, CEM, AM, like that. Now what is happening? That let us say the sea water is coming from here to this side. Now anion exchange membrane, what it does, that it will allow the anions to pass through it, but it will not allow the cations to pass through it. The cation exchange membrane allows the cation to pass through it, but it will not allow the anion to pass through it. So what will happening? Let us say the seawater is coming here. So let us say it has K plus, Na plus, NO3 minus, Cl minus. So what will be happening? That if the NO3 minus will be there, if it is going to this side, okay, NO3 minus will go to this side. Why it will go to this side? Because this anode is there. Anode is there, therefore the minus, whatever the anions will be there, they tends to move this side. Cations will tend to move this side. Why? Because the cathode is here. So now NO3 minus, if it want to move this side, There is a cation exchange membrane, it will not allow it. So this will come here. This cation, it will try to move this anion exchange, it will not allow. It will come back. What is happening here? You see, this cation exchange K plus will come, it will allow. Why? Because it is cation exchange, it will take it and then it will pass it like this. So it will allow the K plus to pass through it. Anion exchange membrane allow the Cl minus to pass through it. So what will happen in this region? There will be no ions in this region. And what will happen to this region? All the ions will be there in this region. Means it becomes concentrate and this become treated. This become concentrate, this become treated. You see, here the treated water is going, here the concentrate water is going. So how we are doing this? How this anion exchange membrane and cation exchange membrane we are preparing? So these are prepared like what we are doing, anion exchange membrane we are having the SO3 minus sulfonated. What we do, sulfonated ions will be embedded in that by the sulfonation process using H2SO4, and in the cation we have a NR3 plus, so that will be there in the cation exchange membrane. So these two type of membranes will be there, and it will pass, one will pass the cation, one will pass the anion. So like that the membranes are prepared and they are placed in this electrodialysis. So what is the use of this electrodialysis? Application in wastewater treatment, we can use, many researchers have used it, like the treatment of ternary wastewater. So 90 to 100% COD removal will be there, color removal will be also there. Then heavy metals can also be removed, like cadmium and tin removal will be there. Then other removal of heavy metals are there. So there are many applications in wastewater treatment using the electrodialysis. Now comes forward. This is a very new technique. Earlier we are using the reverse osmosis. Now comes the forward osmosis. This is the newer technology. Forward osmosis is nothing but it is a simple osmosis. I have told you in osmosis what is happening. From lower concentrate to higher concentrate, or from higher concentrate to lower concentrate. What is happening in osmosis? In osmosis, it is from lower to higher. Okay, we have seen it. This is osmosis. So from fresh to saline it is going. And this is the reverse osmosis. Here we are applying pressure, so water is going like this. So forward osmosis is this process. Forward osmosis is like this. So forward osmosis is water separation process which uses the semi-permeable membrane, and natural energy of osmotic pressure is what? How it is done, we will see. So here what we are doing, we can concentrate if but how this water will go from how the wastewater can be treated by this, do you know? We will see how it will be working. See here, the feed solution is coming here. Now water will not pass from lower concentrate to higher concentrate here. If there is a higher concentration here, then only the water will pass. So how will you give the higher concentration here? That is the problem. How will you give the higher concentration on this side so that the water will pass from here to here? So for that, what we do, we use a draw solution. Draw solution, you can use a sea water or you can see any salty water. So if salty water will be here on this side and the wastewater is on this side, what will happen? What will happen if the wastewater is this side and salty water will be on this side? Salty water will be having more concentration because it has salts. Yes. The water will be passing from here to this side. The only water, okay, water will be passing from this to this side. Why it will pass? Because here more concentrated we are by using the draw solution, that is a high TDS solution or high salty solution. What we are doing, we are making it concentrated so that the water will pass from here to here. So this is a forward and reverse forward osmosis system. So what will happen to here? The wastewater will be concentrated. Wastewater will be concentrated. Let us say that in this wastewater, the let us say COD concentration is 300 milligram per liter. 300 milligram per liter is COD concentration. Okay, in this wastewater. If the water will go outside from this, water will go from this wastewater, COD will increase or decrease? If this wastewater is there, from that, if only water will be going out, it will become a concentrate. Means its volume become very less. COD will increase or decrease?
Sir, COD will increase.
It will increase, yes. But quantity of wastewater will decrease.
Yes.
Okay, so quantity of wastewater will decrease, so it will be very much, you can handle that type of wastewater, or some wastewater which is having very, hazardous type of thing is there. So you can concentrate by this. Sometimes we are using thermal concentration, we are using thermal method for concentrating the waste. Okay, we are heating it for concentrating, but here no heat is required. Only you have to on this side only you have to use the sea solution or the salty solution, and the water is passing through, water is passing from here, and you will get this. Okay, so this is the very new technology nowadays. In the research also people are doing. So you can also to your students or for you also this type of things can be done. Forward osmosis system. Now this osmosis system, forward osmosis, is very helpful in the applications are that product concentration, if you want to concentrate food or beverage products like coffee, beer or coconut water, if you want to concentrate it, you can use this forward osmosis. Then in the industrial facility where the zero liquid discharge, if you want zero liquid discharge, there also you can use this, because you can concentrate your discharge. So there you will get a zero liquid discharge, because now your liquid becomes less and less and less. It becomes so much less, then you can use either multiple effective evaporator for removing that compound which is very toxic. Okay, so in that type of industry, like let us say in pesticide type of industry where it is very hazardous, or other type of industry, there you can use this technology, zero liquid discharge waste disposal. And you can use it for the extracting clean water for reuse also. Okay, that is in both product concentration and wastewater concentration. Forward osmosis moves water from feed solution into draw solution, and draw solution only is what? Draw solution is only having the TDS, it is not having a harmful component. Okay, draw solution is only having the salt, not a harmful component. So that salty water we can reuse for like flushing and other things we can use it. Okay. So this is the for zero liquid discharge we can use it either nowadays instead of UF and NF or RO, FO can be used. Why FO solution is superior to the UF, NF or RO system? What is the superiority of UF, NF, FO solution over RO system or UF, NF? Do you know? No pressure is required here in FO solution. In RO system, it is a pressure driven. Okay, EF and F is pressure driven. FO solution is concentration driven. FO solution is concentration driven. Okay. Now we come to its application. So industrial applications generally O1 wastewater we can remove the cyanide. So you see its application in the wastewater is like if you want to remove cyanides or concentrate where the phenols are there or cyanides are there, we can use this FO. Then removal, reduction in volume of gas filled produced water, then coal mine wastewater desalination, we can use it. So many applications are there. Now you can have a hybrid membrane process also. So hybrid membrane means with two type of membrane system one by one. Like here FO system is there and RO system is there. You see this system is very interesting. Wastewater is coming inside and from here the water is going outside. The seawater we are pumping here. So what is happening to seawater? It is diluted here, okay, because here the only water is coming, it is diluted and it is coming here. That diluted seawater we are putting into RO system, okay. So it is, as we are putting the diluted seawater, the pressure on the RO will be less, okay. So diluted diluted salt water is coming into RO, then the concentrate will be very much salty. So that concentration again we will keeping here and that is transferred to the FO system. So very beautifully we can design this FO RO system to get our wastewater is also concentrated and we are getting very good product water also. So two systems running in a sequence way, okay, that will be very good system. So this type of hybrid membrane process system is also used. Next is the pervaporation technology. Pervaporation, as the name suggests, it is combination of permeation and evaporation. Okay, so what is happening in pervaporation? That feed liquid will be there. When it is passing through the membrane, if you can see here the steps are there. So first step is transfer of main permeating species into bulk feed to the membrane surface. Then step 2 is sorption of permeating species into the membrane. So whatever the membrane is, whatever the constituent is there, it is sorbed on the membrane, okay, and then it is diffused on this side, okay. So step 3 is the diffusion of main permeating species through non-porous membrane, and like this transfer of this will be there. So what is happening? We are heating the mixture here. So due to heating, what is happening? The vapors will be small vapors will be formed that is sorbed on this membrane, and that vapors are then going to this from this membrane to this side, okay. So two things is happening. One is evaporation is happening and other is permeation is happening, okay. So we can use these systems generally for removing like toluene or ethyl acetate. So VOCs, volatile organic compounds, they can be effectively removed using this per evaporation technology. And the last thing is that what will you do to the membrane fouling? Okay. After this, main problem of membrane is the after some time fouling will be taking place. Means these particles, collateral particles or solutes are deposited and dissolved on the membrane, and this becomes clogged or blocked. So there's a flux drop in the membrane. So many things which can cause it: dissolved solids, suspended solids, non-biological organics, and biological organism. They can cause damage to the membrane, or fouling of the membrane is done. So how to prevent this membrane fouling? So there are many methods are there. Either you pre-treat the feed water that is used to, means you decrease the suspended solid. I have told you how to decrease the suspended solid. What you do before RO, keep the microfiltration or ultrafiltration so that the suspended solid will not come. So you pre-treat your feed water to control the membrane fouling. Other thing is back flushing. Back flushing can be also done after some time so that accumulated material will be coming out of the membranes. Third thing is the chemical cleaning. Chemical cleaning by using bleaching or chlorine or other chemicals, we can clean this membranes and then we can use it. So these are the three methods by which we can control the membrane fouling. So I think membrane biological reactor we will already have something, and we will be seeing on this tomorrow also membrane reactor. So I am not going into this. So membrane bioreactors are used. These membranes are used in membrane bioreactors. That is also. So thank you, and we can have a question and answer session. And I think in the chat section I will see if anyone has asked. Yes. So any questions?
Sir, for potable water supply,
Yes.
actually recommended TDS value is 500 or less.
Yes.
That is, if alternate source is not available, then it is relaxed up to 1500. In
Yes.
earlier code, same code, it was up to 1500.
Yes, it was.
Yeah, sir. My point is that the groundwater resources always TDS is higher. Minimum it is 700 to 800, even for
Yes.
alluvium sources. Why RO systems is recommended, sir? I simply cannot understand the reason.
RO system is,
That is advocated. Rather, it will remove the most assimilar form of the alkali earth metals, which is vital for our body.
yes, yes. What is happening that generally in IS system it is written, I think 600. I think it is written 600 more, and in if alternate source is not there, you can go up to 1500 also.
Yes.
Yeah. So that is the when there is no source and water, that is the necessity. Then you have to drink it. So up to 1500 they are allowing it. But if it is more than 600, 700, one thing is that the taste problem is there, and in the long term, maybe I don't know how much research is there. If you take the more tedious water, it will be not much suitable for health also. High tedious water. Therefore, what we are doing, that if more tedious is there, more than 500 or 600, what we are doing, we are then we can use the RO system. What is happening if you use the RO system? Let us say 700 or 800. After the RO system, it will come around 100. Okay. So 100 is the TDS which is generally there in the river water and other water, and 100 is the suitable for our body also, 100 to 150 if you take that type of TDS. Therefore, we can use the RO system in that. But if you don't have the money, or you see the poor people, they are drinking that type of water also, and nothing is happening. But as we are health conscious, we are doing that.
Sir, point is that since last 43 years I am drinking water which is having TDS more than 700 milligrams per liter.
More than
One survey,
700.
yeah, sir, point is one survey was carried out here in my place by Department of Home Science, and there they have divided actually the group of people according to age as well as those who are drinking RO water and those who are not drinking RO water. Surprisingly, the observation was those who are because where I am living is a majority of the area is high valley residential area, and they are having RO at their home also, even in the hostels and all this. Surprisingly, those who are drinking RO water in the young age people, blood pressure noted was higher than what it should be. Second observation was that they were suffering from osteopenia, that is the primary stage of osteoporosis. So is it
Okay.
advocated that we should drink? To be very frank, I have RO at my home also, but I never used to drink that water.
Yes, yes, yes.
Simply,
Yes, this is research now also. If you see on the internet also, it is not clarified how much TDS you are doing, but due to taste problem and everything, what people are doing, if it is more than 700, they are just using the RO system so that it becomes around 1. But
and
many
it,
people I have seen that
yeah,
they are using the RO system for the river water source, which becomes, if you drink that water, it is no taste. It becomes nearly around 0 TDS. So
yeah,
that is not good.
yes,
That is not good.
sir, last week only I had tested one commercial sample, and that was from one of the local industry, RO water manufacturing industry. And my observation was hardness was very less what it should be, and surprisingly chloride concentration found was very high. That it should not be what we expect in the RO system. Now,
In RO.
yeah, sir, so 4 times I had tested, 3 times I had prepared the chemical just to confirm that because I was not convinced with the same thing. But point is that if we are not sure about the membrane quality, this may also happen so that the multivalent cation may be retained and this monovalent may
Yes,
allow to
that
pass
depends.
through.
Yeah, yeah. That membrane quality, if it is not good, that can happen.
So
We have to see the membrane.
how can we trust that also? Because whenever we purchase the RO, sir, those people they are
The
not using.
best thing, we have to purchase some standard companies like I have shown you Doe or DuPont type of RO. They are making very good quality RO. So we have to rely on that. Otherwise, we don't know. We cannot see by the naked eyes or like that.
Yeah.
We cannot
Since
see.
we are technical persons, sir, we are checking it. Majority of the people, I don't know how they are aware of these things or not. Okay, thank
Only
you.
by yes, yes. Any other questions? There is one question by Suchitra Rajpuchawan. At lab scale in photocatalysis process for dye degradation, which filter can be used for dye degradation? I think photocatalysis tomorrow Professor Giyar Shah is going to give. Uh, and if you want to use the filter after that, that depends upon the what is the size of the dye that you want to remove. So depending upon the size, you can use either nanofiltration or the RO that. But dye, if it is organic, you can use the microfiltration and ultrafiltration also. Because organics can remove by that also ultrafiltration, but that depends upon the size of that. Which
Sir, I
type
will
of?
answer that question in detail tomorrow. I will answer that question.
Yes, yes. Okay. Very thankful to Biyasha sir will be answering your question. Okay.
Hello.
Yes.
Actually, sir, it is not my question. It is just part of discussion, you can say. Today, one student called me that some commercial company want to sell their RO machine, and they told that pH is around 10 to 11, 9 to 11.
Hmm.
We wanted to know with me that, sir, is it useful for us or not?
You know, if pH is higher, it may corrosivity will be there, and the material will be degraded fast. So
Yes.
you have to be any material for that you have to maintain the pH in the range of around 6 to 8, like that. If the high pH will be there, then it is likely that membrane will be harm to membrane will be there.
That is the problem, means TB advertisement actually, sir. Alkaline water and all these things, and people don't know what is the real things behind the means RO system. And if, as you told today, that if TDS is around 250 and below 500, it is not having any problem actually.
Yes,
But
yes. This is, in one institute I am having earlier also. In one institute, what is happening? There, the authorities want the RO to be placed as TDS, but TDS was 200 earlier. I was very much, I was like convincing them that we don't require RO, but they said no, RO, how student we have to give to the students, and they will, means RO has become fashion. And what is happening? They invested 4-5 lakhs on that, and within 3 months, that RO, 3-4 months, the membrane system will be, you have to change it after some time, or you have to clean it. So again, 30,000 rupees that new membrane you have to purchase. So then they come to me, what was your idea? I have told you earlier that we can have a normal aqua guard, normal ultrafiltration with UV system. Then they have changed all that our college with that filter, and now it is working after every 1 month or 2 months. Only filter, that ultra filter, that is 100-200 rupees. They are changing, and it is working very fine. So that is the problem.
actually in Baroda, sir, it is TDS around 150 ppm.
Yes. So no RO is required.
Guard is sufficient actually. No need to put RO in.
Yes, RO is not required, because, and in the public system it is not required. In the house you can afford also, but in our colleges to maintain that RO, that is very difficult, because I am, yes.
And RO is damaging our body actually.
Yes, that is 150, 100 you will get a water of around 10 TDS or like that.
Thank you, sir.
Yes. Okay, so any questions are there? If not, then thank you all the participants. We will be meeting tomorrow for the last day session. Another thing I want to tell you, that tomorrow exam is also there in the third session. That MCQ type of exam, so we will be prepared for that also, and we have a valedictory function after that.
Sir, how many questions will be there?
It can have around 30. Around 30.
30 questions.
Around 30 questions.
Okay, it is at the spot, sir. We will give some time limit. Means
we will give some time to you, around 30-40 minutes or like that. We will give some time.
Yes, as today madam is telling.
Okay, so we will inform you also before that. Okay, so how much time and everything, and it may be on the Google. Okay.
लेकिन मुझे डर लगता है तुम कभी पकड़ ना लो.
Okay. I think.
हाँ, सड़वाइन का जाए वहाँ पहुँचे, पकड़ लिए सड़वाइन का.
Yes, sir. Thank you very much, sir. So we will start tomorrow. I think we have to end this session. So I'm going to end.
Okay, Ankit.
Okay, okay, sir. So we'll meet tomorrow early in the morning. I have also created tomorrow's link. So thank you very much, all the participants. Goodbye. We'll meet tomorrow.